All right. Hi, I'm Pablo Caif. I'm a senior engineer working at iFlix with a couple of guys here. Yeah, Adrian and Ben as well. And I'm here to talk to you about my adventures and disadventures with CoreBluetooth. So first, I'm just going to give you just a brief pass about Bluetooth Low Energy. So Bluetooth Low Energy is actually like an evolution of the classic Bluetooth. It came out, I think, version 4 of Bluetooth. And it had a few objectives. The first one was try to reduce the power consumption, which make it really good for IoT stuff because you have very small devices, which just very limited battery life. So it's ideal for that. And it also, you can also have a set of different protocols that you can implement on top of it, which formalizes like the whole thing. And a good thing, different, I think, to what classic Bluetooth is that pairing is optional. So you can actually, the different devices around can be advertising stuff, and you can easily just discover it without having to pair formally to them. Unless, of course, you want to use security. So when you want to use security, then in that case, you actually need to pair. And it supports AS128 and I think AS256. So, yeah. So I was telling you that it has these layers, these multiple protocols, and you can actually define layers. It's kind of like what you do with TCP/IP. So what we got is on the bottom, we got the actual Bluetooth controller, which is talking to the device. On top of that, we can add L2 CAP, which is the link control protocol. And that's something quite similar to what you would see like TCP, right? So you send streams of bytes, and you get streams of bytes. It has like a header and CRC, because you can have situations like device can be moving away, you can start having errors around on the packages. On top of that, we got the attribute layer, the attribute protocol, which allows you to, it basically defines operations such as write services, so write characteristic or write pieces of data, or read or subscribe. And on top of that, we got the GATT, which is the generic attribute protocol, which defines like a set of formal ways of communicating with devices through services and characteristics. And this is pretty cool because you have like a very well-known set of identifiers, for example, for a heartbeat monitor, that if you want to do an app for that, and that heartbeat monitor actually implements the standard, you can just discover the services and start reading its data. And on top of that, you got your app. So L2CAP. So L2CAP is more like a transporter, maybe not as fast. Few things can go wrong, so you need to be very careful. Maybe not as bad as it can go if you end up with all your particles scattered in space. But one of the cool things it has is slow overhead. So all the information you normally have if you were using the attribute protocols or the GATT is that there's a lot of bits that go into the package definition that in this case they're not there. And it's ideal to send a bit larger pieces of information because you can put more bytes into it. But when I'm saying largest pieces of information, I'm actually talking about megabytes, not gigabytes or anything like that. Just to give you an idea of the scale. And it's also great for streaming because you just, as I was saying before, send bytes and receive bytes. But for all the rest of the stuff, it's much easier to use GATT. GATT is more like a shuttle graph. You send smaller payloads. It's a bit safer. There's a lot of stuff around you already predefined that helps you a lot. It defines multiple profiles, which means that, for example, there are specific profiles for heartbeat monitors or sensors or stuff like that. And it's very easy to get started. There are a whole set of libraries in all different platforms which allow you pretty easily to discover these services and characteristics that I was telling you. And the way the whole thing is modeled is into a central, which is the part that wants the data, and the peripheral, which is the part that has the data. So in this case, your peripheral would be heartbeat monitor. So to get a little bit more into detail, say I have my own peripheral heartbeat monitor. This heartbeat monitor can be advertising different services. So for example, one of the services could be the heartbeat. Another one could be battery level. And each service can have multiple characteristics. For example, in the battery case, we could have the battery level itself, the charge, the percentage. And we could have maybe, I don't know, how wear off is the battery. And we could decide to throw down the device. No, maybe that's not a good idea. And then we have the values and descriptors. So the descriptors will tell us what that characteristic has, or what sort of types you have. For example, if it's a string or if it is a float. And the value itself is what you are interested to read, what you want to actually read or write. So CoreBluetooth is the Apple implementation of it's the library, the framework that allows you to access to Bluetooth LE. And the way it has been defined is that it models all this communication that I was telling you between the peripheral and central, and all the GATT sort of a paradigm where you have services, characteristics, and a very cool thing, different than classic Bluetooth, is you don't need to be in the MFI program. So you can just connect to any device that is advertising services and start reading stuff. It supports state restoration, which is pretty cool. That means that, for example, if you are, I don't know, doing a firmware update, and for some reason your app gets terminated in the background, iOS will actually keep that connection alive and will keep trying to receive or send the bytes, and you will get like a callback. Your app will get started, and then you can actually start restoring the state and reconnecting and getting everything back together. And as of iOS 11, they are guaranteeing the latency as low as 15 milliseconds only on the iPhone, on the latest iPhones, and on the Mac, and I think on the latest iPads, the iPads Pro. But on the rest of the stuff, such as the Apple TV and the Apple Watch, I think it's 30 milliseconds. It also, as of iOS 11, they started supporting L2CAP, which is pretty cool because you can actually do streaming. The way the whole communication is implemented is through delegates and async APIs. So you do a call, you assign a delegate, and then you get a callback on the delegate. So to get a little bit more into details, My green boxes are the CBCentral managers. So this is, for example, you have on your mobile phone, you want to read heartbeats, right? So you instantiate the CBCentral manager. It goes and assign the delegate, the CBCentral manager delegate, powers off the hardware, and you eventually get a state change callback, which it will tell you that whether the hardware is on or if it's not available. Then you can start scanning for peripherals, and then you get a callback telling you that it has discovered peripherals. So what it will do, it will start coalescing the packages. Each peripheral sends packages telling you what's their ID and the signal and stuff like that. So it will coalesce and just send you to a callback every time it discovers a peripheral. Then you can connect to the peripheral, and you get a callback telling you that you have connected to a peripheral. And then you need to implement or adopt the CB peripheral delegate. And you also need to use the peripheral that you got in your initial, the one you're actually trying to connect. So when you do that, you can start discovering for services. Eventually, then you can try to get the characteristics. And then you can actually write. So it's like a lengthy process. And along the way, you actually need to start saving stuff. So for example, if you're interested in reading or writing a specific characteristic, you actually need to assign it to a variable. And you can also read, and you get callbacks for that. And the cool thing is you can also listen for notifications. So you can subscribe to a characteristic that changes frequently, and you can just, you will get a callback, read characteristic read value every time any value has arrived. So I'm going to give you a demo. So what I've been working on, it's I'm working on an app that connects to an actual hardware, but I can't really talk much about the actual app, so I built like a similar example. So I imagine myself that I'm working on a nuclear plant, and I need a Geiger meter to try to stay myself safe from nuclear waste. So what I did is I built like a very simple and rudimentary Mac app. Which sets itself as a peripheral and starts advertising a few custom services. So that's my app there. And if I start a service, I can actually use an app. This will be just like this is an app that I used also to actually do the development because it's easier to see the services and characteristics being advertised. So, should be able to see my computer. Right clicks, that's it. Okay, looks like there's a lot of. Yep. And you can see there, I don't know if you're able to read from there, but I got my Geiger counter, which I can listen for notifications, and you can see on my peripheral that it has discovered that someone has subscribed to that. And I can, for example, send commands through this one. This is an actual write characteristic. And I can get the battery. This is like a custom battery service. I could have implemented the actual standard one, but it will overlap with the Mac. So you can see the battery level. What I'm doing is I'm just generating random numbers. So it's just gonna, every time I read it, it's just gonna give me a random number. So then I went and built an actual iOS app that it will set itself as an actual peripheral. sorry, as a central. So we'll try to access to that peripheral, virtual peripheral defining here. So if I run it on my phone, and hopefully I can connect. So what this one will do, it will connect to that service, that Geiger meter service that I was showing to you, and it will subscribe to one of the characteristics that is giving me the radiation readings. And it will also show me the battery and stuff like that. So as soon as I connect, you can see how I'm sending about every 400 milliseconds a new value. So this one is getting the notifications. And you can see there on the top, the battery is changing 20%, 39%. And you can see on the actual server, so sort of my peripheral side, how it's actually generating the new values. And I can send a command, this is the right part, to sort of stop, stand by, or I can set another command to get it going and continue. Yeah, so that's it.
You're telling the Bluetooth device to start and stop sending?
Yes, exactly, yeah. So I thought it wouldn't really make much sense going through all the codes. I'm gonna put it in GitHub, if you're curious. But going back to the presentation, there were a few learnings that I had with all my experience, my adventures. So first thing that I easily missed, that seems obvious at this point, is you need to save the peripheral when you want. As soon as you get it and you want to connect to it, you need to save it to a variable because, of course, it's going to get released. And even if you say connect, it's just going to disappear and it's not going to connect. I was having some problems with the hardware. The hardware was sending, we weren't getting the packages as quick as we wanted. And something that if you are working, someone building the hardware, it's always a good idea to ask them to send a negotiation or ask your actual device to negotiate a shorter connection time. That's the part that I was telling you before. For example, 15 milliseconds. You can actually, on iOS, on the CoreBluetooth, it's very easy to do. You can tell, as soon as you connect to a central, you can tell it, set the connection time to low. So I will try to go to the lowest one. But if not, of course, because it wants to save battery, it will try to negotiate a higher one. The state restoration is pretty tricky. It's not easy to implement because you actually need to get to the state you were before the app was terminated. This is, again, when the app gets terminated and you get new data coming, your app gets started again, and then you do the app did finish launching, and then you need to reinstantiate your peripheral delegate, your CBCentral peripheral, CBCentral manager, and then you get like callbacks, and you need to rebuild your whole state, which is pretty tricky. And it's always a good idea to implement the delegate handle errors, like all the methods that tells you there was an error, whether when you were trying to connect or when you were trying to read something, because it will tell you interesting stuff. So a lot of times when you can get things working, get a lot of information from there. Another one very interesting to run into is when you define a characteristic, for example, the battery level, if you create it and set an initial value, when you try to update it, it will just ignore every time you try to change the value. So you need to set it initially as nil. And the security and pairing can be tricky as well. I managed to get it working with the hardware that I was working with, and also between two iOS devices, but for some reason I couldn't manage to get it working between the Mac and the iOS device. And there are always good things to do, like best practices. The first one is the battery is always a precious thing in your user's device. So don't just scan the whole time. Scan as soon as you get whatever you're interested in, stop scanning, because that will reduce quite a lot of the power consumption. Actually, to reduce even more the power consumption when you're actually doing the scanning, you can say which services, you can specify which services you're interested in. So you can just give a list of services. And instead of, if you, in my case, as you were seeing my readings of radiation readings, it's always a good idea to subscribe rather than pull for new values. Another cool one is iOS has a nice cache of connections. So if I ever connected to a device, it will have an internal cache, so you can actually do a call to get all the previously known peripherals that you once connected to, and then you can try to reconnect to that one. And you can also get the already connected peripherals. Remember that you could be reinstantiating and could be something already connected. And that will save you the first step, the scan. You might not need to scan. Then if you can't really connect to the peripheral, then you can start scanning. Leverage all what GATT provides you, using services, advertising stuff as services and characteristics. If you're using like a predefined standard, it's always a great idea to go and read the GATT database and find what you're interested in. If you're defining your own services and characteristics, you can always generate your own UUIDs for those services and characteristics. And once you read and you got all the stuff you need, don't forget to disconnect. And the last one, sorry. The last one is write a simulator. For me, it was very good because I didn't have the hardware with me all the time. So that's why I wrote the bit on the Mac, which ended up being very useful. So a few places where you can find more information. The Apple Bluetooth guide and docs are always really good to get more information. There is also the actual GATT specification that I was telling you. There are 2 sessions, 2013 703 WWDC sessions and 2017 last year. They also have a very good information. The 2 apps that I was showing, one of them that I was showing to you before is called Light Blue app, and there is another one, NRF Connect. And they're really good for these initial states when you want to check that the hardware is actually advertising itself properly with the right numbers and right IDs and stuff like that, and is publishing the right services. And that's the link to my 2 projects, the Mac one and the iOS one. So that's it. Any questions?
Is what you haven't shown us, has that got anything to do with radiation?
So you're saying if there is actually radiation being emitted here? Yeah. Now, what I'm doing is nothing to do with that. I was just trying to come up with something that it sends packages very frequently. And I was also trying to play with the core animation, same thing that Cheryl was doing, so I was trying to get the needle moving. Yeah. Yes?
I couldn't encode the first symbol on your show.
That's an I.
A?
I. That's yeah. Square root of -1.
All right.
That's I.
Any more questions, guys? Thank you, Pablo.
All right. Thank you.